my name is Paul Pasulka, Ivy Masters Learning Center at ivymasters.com, and today we're going to look at Test 7, Section 3, number 13, which reads, which of the following expressions is equivalent to that? So what am I going to do here? Well, whenever I have variables in the answer choices, what I can do is I can pick a number, plug it into the original, see what I get as my answer, plug that same number into each answer choice, and see what gives me the same answer. Logically, they're going to be equivalents. I'm not going to pick any number for x. I'm going to look at the bottom of the fraction. It says x minus 3. So what do I pick for x? I'm going to pick 4. Why do I pick 4? Because I want the bottom of the fraction to be 1. Why do I want the bottom of the fraction to be 1? Because anything over 1 is a whole number. It's easier to work with. So when I plug it into the original, in place of every x I put 4. So it becomes 4 squared minus 2 times 4 minus 5 over 4 minus 3. And then 4 squared is 16. 2 times 4 is 8 minus 5 over 1. 16 minus 8 is 8 minus 5, and over 1 is just 1, so that's going to give you 3. So when your x is 4, the answer to the question is 3. So what I'm going to do is I'm going to plug 4 into each answer choice and see what gives me 3. Notice I don't have to plug into the denominator here because 4 minus 3 of course is 1. So I could just do 4 minus 5 minus 20. But plugging my 4 into answer choice A, I could see I get a negative, so that's gone. Same thing with B. I need a positive 3. Answer choice C, 4 plus 1 is 5 minus 8 is negative 3. That's gone. And answer choice D, 4 plus 1 is 5 minus 2 will give me that positive 3. So that is the quote-unquote tips and tricks, strategic approach to do this question. How would you do this in math class? Well, in math class, this looks like an improper fraction. It looks like 7 over 3. And the answer choices look like mixed numbers. They look like, notice if I divide 3 into 7, what it goes twice, and I multiply, I get 6, I subtract, I get 1. And what we'd call the remainder goes on top of the number outside the house, so it's 2 and 1/3. I can do the same thing with polynomials. I can do x minus 3 on the outside. On the inside, I get x squared minus 2x minus 5. And doing long division, how many times does x go into x squared? It goes x times. How do I know? Because x times x will give you x squared. It's like a fact family. If dividing it in gives you a certain something, then multiplying those two should give you what you were originally dividing into. X times negative 3 is negative 3x. Then I got to subtract this, which means I got to subtract both monomials. Change sign, and these cancel, and I get x minus 5. So how many times does x go into x? Notice I'm just looking at the leading monomials there. It goes once, so I put plus 1. When I apply x minus 3 times 1, I get x minus 3. Make sure you multiply by the second monomial there. And then when I subtract it, it's like I change sign, and add it, the same thing. I get negative 2. So it's x plus 1 minus 2, which is this bottom one that I throw up top, over x minus 3, which is what's outside the house. It's the same thing I did over here with the numbers. And again, that matches answer choice D. There's one more variation that you can do here, which is synthetic division. So since the bottom is x minus 3, then what I could do is I could put a positive 3 up here, and then I could put the coefficient of everything here over here. So the coefficient of x squared is 1, the coefficient of x is negative 2, and then you just got your constant negative 5. And I bring it down, I bring it down, my 1, and then when I multiply I get 3, and I add it down, and I get 1, and then I multiply, I get 3, and then I add it down, I get negative 2. And then you drop 1 power. So the original was x squared, so this is 1x, this is a positive 1, and this is minus 2, so it's minus 2 over what I was dividing in already, which is x minus 3. So once again, you've got x plus 1 minus 2 over x minus 3. Thank you for joining us today. If you like this video, click like. You can share it with someone who has trouble with these kind of like improper polynomials. If there's any question you'd like to see answered from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.